Welcome to lecture 13, 8051 Timer and Counter Programming Introduction. In this lecture, I just going to be cover what are the register which we are going to be used for timer and counter programming. The timer and counter is an important peripheral is available in the 8051 microcontroller. This is a special function register. The address it will start from 80 to FF. In this, the 6 register which are related to the timer and counter: TH1, TH0, TL1, TL0, TMOD and TCON register. With the help of these 6 register, which we are going to be perform the timer and counter program. The 8051 consists of two 16-bit timer and counter. How we can claim it is a 16-bit timer and counter? Because 8051 is a 8-bit microcontroller, how it is possible to make two 16-bit timer and counter? In SFR, we having the registers like TL0 and TH0, TL1, TH1. We combine TL0 and TH0, we make the 16-bit register. This register we call it as timer 0 register. So we can claim it is the one 16-bit timer counter. The second case, the TL1 register, TH1 register, we combine both, we can make timer 1 register. So it is a 16-bit timer 1 register. We can claim the second 16-bit timer and counter. So in 8051 it consists of two 16-bit timer and counter. The next very important in timer and counter, the TMOD register. It is very important register whether your counter or timer or which timer or which counter we are going to be select based on this TMOD register only. Here lower byte the timer 0, upper 4 byte it is a timer 1. The pins which are going to be used for timer 0 it is same as timer 1. Once we know about the operation of timer 0, that is lower 4 byte, okay, that's same for timer 1 operation also. First we can take M0 and M1. This is for mode selection. The timer 0 and timer 1 work with 4 modes of operation, that is mode 0, mode 1, mode 2, mode 3, based on the selection of this M0 and M1. If it is 0, 0, it is mode 0, 13-bit timer mode. If it is 1, 16-bit timer mode. If it is 2, 8-bit auto reload, and 3, split timer mode. Then come to this C/T bar. These all the 8 bits. As a programmer, through software only we can configure this all the 8 pins. No externally through the physical pin of 8051 we are not going to be configure these pins. With the help of software we can configure this all the pins. According to that your timer is going to be work. Okay, fine. The next pin C/T. For example, as a programmer you want this timer and counter, it works as a timer operation. You make this bit as 0. If you make this bit as 0, this timer and counter work as a timer operation. The timer operation, the input from the internal system clock. I will explain you what is the internal system clock in the subsequent slides. If it is 0, input from the internal system clock. If it is 1, as a programmer you make this is 1, it's set for counter operation, the input from TX input pin. The next come to the gate. This is also very important bit which the software, through software only we can configure this gate, and through external hardware also we can configure. I will explain. If it is gate bit is equal to 0, then no need to worry about TX, INTX pin. Once you make this gate bit as 0, this timer and counter is going to be enabled. No need to worry about any external things. If you make, as a programmer, you make gate bit as 1, you must enable this INTX pin high. Then only this timer and counter is going to be enabled. I will explain what is INTX, TRX, what is input from internal system clock, and for counter operation input from TX input pin. I will explain this in the subsequent slides. Here, this is the diagram which is going to be explained in detail about timer and counter programming. I open this diagram in the paint and can able to mark very important points. The first, the M0 and the M1, which is used for mode selection, which mode you want to operate. Based on that mode selection you can work. The next, the bit we can use, it is a C/T bar is equal to 0. In the previous slide we discussed, it will get the it will use for the timer operation, it will get from the internal system clock. So this clock X-tal oscillator we connected in between the 18th and 19th pin of 8051. The internal itself there is a divided by 12 circuitry. Once we will get this operation, the output we will get 1.085 microsecond. For example, here you see, find the machine cycle for 11.0592 megahertz. So that is the frequency we are applying through this crystal oscillator. The inside there is a divided by 12 network. That's why that frequency is divided by 12. You will get 921.6 kilohertz. You inverse of this frequency, you will get the time period of 1.085 microsecond. Okay, so that's why for C/T bar equal to 0, it get the input from the internal system clock. That is the meaning of this 0. If C/T bar equal to 1, so get the input from the T1 pin in case of timer 1. In case of timer 0, it take from P3.4. So C/T bar equal to 1, it is a counter operation. It get the input from the external event. So what is difference between the timer and counter means, the timer is used to set the time delay between two events. For example, you are connecting one LED in the port of 8051. 5 millisecond once your LED is going to be switch on, switch off. With the help of this internal system clock, we can perform the time delay. For example, I want to count the external event which are connected physically in the pin of 15th pin. For example, externally you can clock one clock source. From this clock source only you can able to count the counter operation. It is going to be performed the external clock. Suppose you are connecting one proximity sensor across the P3.5. For example, the proximity sensor you are using in the automatic car parking area. Whenever the car is passing the proximity sensor, it is going to be detect. Whenever it is the high to low pulse is detect, so the register is going to be incremented. So one car inside the parking area. Again, one more, the car is passing the proximity sensor. The next pulse is detected. So it is the received through this pin, and through this it is going to be count. Now the register is incremented by the next one, so the total count it is 2. Okay, now another important register of 8051 timer and counter, it is TCON register. These 4 register we are not going to be used in this timer and counter programming. We are using only this upper 4 bytes. I take here as a timer 1. I take a timer 1 16 bit. This is timer 1. That's why I represented everywhere T1, TR1, TH1, TL1 and TF now. The same configuration for the timer 0 also, no need to confuse. Suppose I am using timer 1. So what are the two important registers? Two important pins are important. One is TR1, another one is TF1. The TR1, in the programmer's hand, you make this bit as 1. Then only this the program, what is that, the timer is going to be start or counter is going to be start, or else it won't begin. Another pin is related to timer 1, it is TF1. Once this TH1 and THL, it is, you have to be connected over here. If it is overflow in the sense it will reach the maximum value FF, this TF1 bit is going to be set, it is going to be set. So it is automatically set, not in the programmer's hand. Suppose if we want to reset this TF1, as a programmer you have to be reset. Okay, so that is a function of these two register for timer 1 operation. If timer 0 operation, the same function is going to be performed. Okay, we discussed TR1, we discussed what is C slash T bar equal to 0, what will happen. C slash T bar equal to 1, what happened? It will take from the external count. Now, the very important, the pin in the TMOD register is a gate. If the gate is equal to 0, this is configured by the programmer. There is no need to worry about the external. If it is 0, the output, it is inverter is 1, so it is a OR gate 1. So 1 1 it become 1, so this switch is going to be closed. If it is 0, no issue. If it is 1, gate is equal to 1, what becomes this 1? Here becomes 0. So INT1 pin should be 1, then only we will get this output as 1, or else this timer and counter won't enable. How to make this INT1 pin enable? Here INT1 pin is there. You can make this INTN pin, you make high to low, then only high to low plus gate you can give the 1, so output becomes 0. So INT pin, what is that, detect it is 1, the output is 1, this timer and counter is going to be enabled. The two way, gate equal to 0, no need to worry about this pin. If gate equal to 1, you can make this the physical pin, the externally you can physically you can connect some what is the switch or the clock you can apply to make this pin as 1 to enable this timer and counter. Okay, first we can perform the, how to perform the timer operation. Timer operation, C slash T bar should be 0, then only it will work as a timer. If it is C slash T bar equal to 1, it will perform the counter operation. So C slash T bar equal to 0, it is a timer operation. The clock divided by 12. So this switch is closed. There is a register. Here for each 1.085 microsecond, this register is going to be increment 0001. For example, 0 0 0 0. That is the value you loaded in this register. After that, through this clock, anyway the clock source is continuously giving for the microcontroller, it is continuously divided by 12, and each the 1.085 microsecond, this register is going to be increment. The next increment it becomes 1, next increment becomes 2. What is the difference between these two? Even it is 1.085 microsecond. So that's all about the timer operation. It will take the help from the internal system clock, it is going to be performed. Once it will reach the FF, this TF1 bit is 1, it is automatically set, not by the programmer hand. Again, once it's set, as a programmer you make this TF1 bit as 0, then only the next operation is going to be performed. Okay, the next is C slash T bar equal to 1. This control is come over here. So there is connection, there is no connection between the internal system clock. So now T1, where I connected clock source or any proximity sensor, you can connect it over here. It is going to be count to the external event. I told one car pass that proximity, this counter is, this register is incremented by 1. If the second car is detected, again this register is incremented by 1, and so on. For example, after 24 hours we can see how many car is parked in the inside the parking area. So the counter is used to be perform the external event. The timer is used to, what is that, give the fixed or exact time delay for some the timing events, like 5 millisecond once LED should be on, or 5 millisecond my LED should be off. For that cases we can use this, the timer. The timer is giving the time delay between two events, and this counter is going to be count the external count. I hope you understand the gate pin, what is the use of TR1, what is the use of this C slash T bar equal to 1 counter operation, C slash T bar equal to 0 it is a timer operation, and TH1 TL1 it is a register. Here only whatever the event or the timing, it is going to be the incremental over in this register only. That's all about this diagram. This diagram is same for mode 0, mode 1 and mode 2, and mode 3 is little bit different. It is 8-bit timer split mode. So at a time we can able to perform two 8-bit timer. How it possible? The same circuitry, but you have to be increment the external event or the timer operation. We can use TL0 for the first 8-bit timer. First 8-bit timer I can use TL0. For overflow detection I am using TF0. The second 8-bit timer I am using TH0, TF0. But here I am using only timer 0. Okay, timer 0 I can able to perform two 8-bit timer operation with the help of mode 3. That is the beauty of split operation timer 0. Here I want to run this 8-bit timer. You make TR0 should be 1, the programmer hand. Gate pin is also programmer's hand. You make this is 0. Okay, C slash T bar equal to 0. It will be the internal system clock. Okay, through that this register is going to be increment. Once getting overflow, that is the maximum FF. Thus TF0 is going to be overflow, that is 1. Again programmer make this TF0 should be 0 for the next timing operation. For second counter you make TR1. Okay, timer 0 I am using two 8-bit registers, TL0 for first 8-bit timer, TH0 for second 8-bit timer. For overflow TF0 I am using for first 8-bit, TF1 for second 8-bit. For run the first timer I am using TR0 pin. For run the second timer I am using TR1. So at the same time we can able to perform two 8-bit timer operation possible. Okay, thank you.